So welcome back. This is our fourth and final video for this pre-lab. And this pre-lab is going over the lines of code we need to be able to run our model. And also it's going to look at sort of the beauty of abstract models and how easy it is to sort of expand and contract our abstract models just using our data file. So again, this video is going over solving the model and interpreting our solution. So to start with creating and solving a model instance. We're going to use these lines of code that you see here. These first 4 lines, they're basically merging our model and our data files together to create an instance. These second set of lines are solving that instance. And then this final batch of lines is checking our solver status and printing the results. So before I jump into the rest of the video, I just want to say that if you're doing these labs in Google Colab, like the files that you downloaded, you'll want to do a couple things differently. So when you see the file path for the file that we're going to download, you're going to want to make sure you put the whole file path in there to whatever Google directory that you're using. And then for the line where we're loading the GLPK solver, that looks a little bit different in Google Colab too. So your line will look more like down here where you specify the solver and then you have to give a path to the executable. Everything else should be the same though. So we'll first take just a slightly closer look at these first 4 lines. These first 4 lines are the lines that are basically creating a data portal object. That data portal object is then reading in our data file, and then it's merging our data file with our model file to create an instance. And then finally it's printing our concrete model out. And these lines are the exact same lines of code that we saw in CSLabstract.py, so if you want a bit more detail of them, go back to, I believe that was pre-lab 4. And the only thing different here is that we're loading the OJ data file instead of a CSL related data file. So we changed the data file that we're loading, but the lines are the same. You can copy and paste them straight from your CSL abstract model. And we're also printing out the lines of code that are created here. So we're printing out our instance. And that will allow us to see what our objective function actually is and what our constraints actually look like. The next lines of code are related to actually solving or running the instance. So if we look more closely at those lines of code, again, they're the exact same lines as we've seen previously, except this time, since we're going to be checking the solver status, we want to store our solved results in an object. So we've just said results equals optimizer.solve instance, and it's going to store some of those termination conditions and solver statuses in that results object. And we want to be sure that when we're solving our model, that we solve the instance instead of the model, because the model doesn't have any information in it. It's only once we join that model with our data file where we've created an instance that we've created something that can actually be solved. And then finally, this large block of code we see here, we've seen that block of code before. It's the exact same block of code that we saw in our CSL concrete.py example. So you can go right to that CSL concrete model file, grab these lines of code, and the only thing you're going to change is instead of displaying the model, so instead of model.display, we're going to say instance.display because it's the instance that we solved. So then the question becomes, do we want to buy quality 4 oranges? So let's take a look at this model and data file in action. So if we take a look at our model file, It's fairly long. We've got quite a few lines, about 44, well, let's see, up to line 38 is basically our model definition. And then this last chunk of code from line 40 to 56, that is solving our model and making sure it ran okay. And then we see our data file over here, where we've got our original problem with qualities 6 and 9 and our original products, juice and bags. We had profits and required qualities and certain amounts available. So if I run this model file, we should sort of see our starting point. And some of the things you'll notice is that for every decision variable, it's going to print out what the decision variable values are. So we have how many quality 6 are we putting in bags? About 93,000. And then there's a whole bunch of decision variable values. The last one is how many quality 9s are we putting in juice? About 53,000. And we see here that we're making a profit of 78,000. But another nice thing that we can see, because we use this line here, instance.pprint, because we put that line in, before we even see the results up above them, we can see what our model actually is. So we can see, information about our parameters, and we can check that the parameters are loaded correctly. We can see that it's made the right number of decision variables. We see that objective function written out, so there's no longer any cryptic summation signs. We see exactly what's being added. So for example, we see that it's taking 45 cents times however many quality 9s we're putting in the juice, and it's taking 30 cents times however many quality 9s we're putting in the bags. And it's adding up similar components for our quality 6s. So if you're not sure if you've done your double summation right, or if you've coded your objective function like you want it to, you can always use the model or instance.pprint, and you can see exactly what's been made. And then again, we see for our constraints, for our don't exceed the amount of quality of a certain quality constraint, we see we have one for quality 6, and we have one for quality 9, so that's what we expect. And then when we're checking the quality of each of our products, we see that we have a constraint that was made for bags and a constraint that was made for juice. So that pprint function is super useful for making sure that everything is being made as you want it to. Alright, so down here we see that we made 78,000, and the question in our first in-class PIOMO related lab was, do we want to buy quality 4 oranges? If someone comes and offers us 20,000 of them, do we want to buy them for $1,500? So right now, if I look in my data file, I don't see quality 4 oranges anywhere, but I can quickly add them. I could add quality 4 to my quality set, and I could add quality 4 to my amount available parameter. So I'm going to say quality 4, and I think we were able to purchase 20,000 pounds of these quality 4 oranges. So that took me about 2 seconds to add. I didn't need to change my model file at all. And when I press play, we can see that in our results, we now see results for quality 4 oranges and how many we're going to put into bags and how many we're going to put into juice. Turns out nothing. And if we were to look up at our constraints that are being made, we see those quality 4s appearing in our constraints. So when we're trying to meet our required quality for juice and bags, we see those quality 4s show up. When we're making sure we're not using more quality 4 oranges than we have available, we see we have a new constraint for that. That constraint wasn't there before. And we also see those quality 4s show up in our objective function. So these quality 4s showed up everywhere, and all we needed to do is change our data file. And if we look at our profit's the exact same, still $78,000, and we're not using any of these quality 4 oranges in juice or bags, so it's probably not a good idea to be buying them. And then the next question in that lab asked, well, if we don't want to buy quality 4 oranges, what does the quality need to be before we want to buy them? And a lot of people did like guess and check, where they went and they updated their model files with new constraints for different qualities, and you had to make sure that you changed all of the different constraints, and it was sort of a pain. But here, that kind of question can be answered really easily. We'll just change these qualities to 5. Make sure that we save that data file, and then run our model file. And we see that, now it's using quality 5 oranges in our model, but we're still not using any quality 5s in any of our products. And our objective function is still 7,800, so not an improvement yet. So the next thing we could try is 6. So I'm just going to remove the quality 5 oranges and increase the quality 6 amount by 20,000. So we'll put that up to 140,000. Make sure that gets saved. Run our model. And we can see now, once we have more quality 6 oranges, our profit has gone up to 81,000. That's definitely $1,500 more than 78,000. So it would be a good idea to buy 20,000 oranges if they were quality 6, if someone wanted $1,500 for them. And then we could also make our model super complicated very quickly. So maybe someone came with a truck and it had quality 4 and quality 5, and maybe even some quality 10 oranges on it. I could add those different qualities to my quality set. I just need to quickly add how much of each quality was on that truck. So maybe it's 50,000 quality 4s, 25,000 quality 5s, and then maybe only 3,000 pounds of quality 10. And then maybe our orange juice company has also started making other products. So maybe they want to make marmalade, and they're also curious about popsicles and whether they should be making popsicles. So we could add more products to our product set. And if we add more products, we want to make sure that we tell them the profit and the required quality for each of those products. So we'll add our marmalade to these parameters. Maybe marmalade is medium profit, 37 cents, and it has a required quality of 6. And popsicles, maybe are, I don't know, maybe they don't make much profit. 5 cents, and they have a required quality of 3. And if CSL wanted to know what they should do with these products, we just add them to our data file, run our model file, and we can very quickly see, one, we look up at our p-print statements. We now have a constraint for each one of our qualities that's trying to make sure we don't use more of that quality than we have available. And when we're checking the quality of our products, we now have a quality constraint for juice, bags, popsicles, and marmalade. And we see also, if we look at our objective function, it's a lot longer now because we have to add in the profit from all those new products and all those new qualities. And then looking down here at our solution, turns out that we're going to make marmalade with our quality 4s. We're also going to make marmalade with our quality 5s. Our quality 6s are going to go into 2 products, juice and marmalade. Our quality 9s are headed into juice and marmalade. And then our quality 10s are going to be used exclusively for marmalade. And we'd make $125,000 if we had these oranges on hand. So again, that was super easy to add a bunch of products and qualities to our model, and our model just automatically expanded and contracted. So if you ever have sort of the time available to pause and think about making an abstract model, it really does make it a lot more scalable and flexible when you want to make changes in the future.